Hello friends, my name is Manoj Chaudhary and welcome to today's session on sequences and series in which we will revise arithmetic progression. So if you remember in my previous video, we already discussed all the basic things of sequences and series. What is a sequence, what is a series, what exactly is the meaning of progression, and we also discussed the three types of progressions, that is arithmetic progression, geometric progression and harmonic progression, and how to identify the AP, GP and HP. So that one was the introductory part of the sequences and series. So let's revise arithmetic progression. So now, how to identify a arithmetic progression? There is one simple way in which you can identify a arithmetic progression. So do a simple thing, try to observe the difference between two successive terms. So friends, successive term means one after the another. Try to observe difference between two successive terms. If that difference between two successive terms is every time constant, then we say that sequence is in AP. So okay, let's understand this particular thing using this example. If I say the sequence is 1, 3, 5, 7, 9, 11 and so on. So how to identify whether the sequence is in AP or not? The thing is very simple, friends. Just try to take difference between two successive terms like 3 and 1. So what is 3 minus 1? Answer is 2. What is 5 minus 3? Again the answer is 2. What is 7 minus 5? Again the answer is 2. If you do calculations on and on, you will observe that every time the difference between two successive terms is 2. So this is what they are trying to tell you. If the difference between two successive terms is constant throughout, if you observe this 2 is never changing in this particular case, means this sequence is in arithmetic progression. This is the simple way in which you can identify the sequence in arithmetic progression. So and there are few basic things that you have to remember from this any sequence. This is nothing but the first term of sequence. So friends, we always name the first term of sequence as A, and whatever this 2 which is coming every time as a difference is called common difference. This 2 is called common difference, and we denote this common difference by D. So these are the two basic terminologies that you have to remember. First term we always denote it by A and common difference by D. Okay, then further after identifying an arithmetic progression, they will ask you to write nth term of arithmetic progression. So let's try to understand what is the meaning of nth term of AP or arithmetic progression. So for the sake of understanding, here I am mentioning T1 as a first term, T2 as a second term, that is nothing but 3, T3 is 5, T4 is 7, T5 is 9, T6 is 11, and things goes on, and Tn comes. So many times students get confused in Tn. So let me tell you, friends, Tn is the nth term, and nth term is not a last term of the sequence. This is the main confusion, So many times students assume nth term as the last term, but let me tell you, friends, nth term or Tn is not a last term of the sequence, but it is always a general term of the sequence. Tn is nothing but general term of the sequence. What is the meaning of general term? This Tn always represents each and every term of the sequence. If I am talking about Tn, so Tn may represent T1, T2, T3, T4, T5, T6, or the term that we don't know like T20 or T7 or T15, anything. So Tn represent any particular number from that sequence. So it's not like that Tn is the last term of the sequence, Okay, let's try to identify a formula for the T1. So if you observe here, the first term of the sequence is 1. So to obtain the second term, do a simple thing. Just add the common difference in it. You will get the third term, second term, right? Which is nothing but 3 in this sequence. Try to observe in the sequence. If you want third term, do a simple thing. Just add this D in this second term. So, right, what is this 3? So this is 1 plus 2. I am adding one more common difference in it. Obviously, you will get 5. So if you observe here, if I want the next term, every time go on adding the common difference. Here I am adding one more common difference that will leads to 7. So right. So what is your observation? So first term is nothing but 1. There's no common difference. No common difference means I am expressing this as 0 times 2. Right. So let's mention difference in this case is 2. So it's a 0 times 2. Okay. What about second term? If you observe, it is 1 plus common difference is 2, but it is 1 time. Then what is third term? Third term is 1 plus common difference is 2, but it is 2 times. Right. What about fourth term? If you observe, it is 1 plus common difference. I am talking about this 2 which appears 3 times. So means we can express it as 3 times. Right. Okay, so here I am mentioning this thing in the form of symbols. The first term of arithmetic progression is A. If you want the next term, simply add common difference in it. You will get the next term. So, right. If you want the third term, then please add one more D in it. That is 2D. You will get T3. If you want T4, then please add one more D in it. You will get 3 times D. If you want T5, answer is 1 plus 4D. While obtaining these terms in a sequence, please observe there is a definite rule or definite pattern in this structure. And let me explain you that hidden thing. So here, if you observe in a first term, there is no D available, means coefficient of D is 0 here. In the second term, if you observe, coefficient of D is 1. Right, so try to observe everything lies in this coefficient of D. As far as first term is concerned, coefficient is 0. In second term, coefficient of D is 1. In third term, coefficient of D is 2. In fourth term, coefficient of D is 3. In fifth term, coefficient of D is 4. Right? What if I want nth term, any random term in arithmetic progression? If you observe, in each and every term, this A is following everywhere. So, right. So, just follow this structure. Just follow this entire observation for this nth term. This A, I am writing directly. Plus, what about D? If you observe here, in each and every term, D is present. Only thing is its coefficient is changing, not the D. So, here I am continuing this D also. And the real trick or the real thing lies in coefficient of D. And please try to observe here. If it is the first term, coefficient of D is 0. If it is a second term, coefficient of D is 1. If it is a third term, coefficient of D is 2. If it is a fourth term, coefficient of D is 3. If it is a fifth term, coefficient of D is 4. So what I am trying to tell you is, if it is a fifth term, then it is less than 1. Are you observing? If it is 5, then it is less than 1. If it is 4, then it is less than 1, that is 3. So friends, if it is a n, then what will be the coefficient of D? Obviously, less than 1. So, right? So, if it is n, then the coefficient of D will be less than 1, that is n minus 1. And friends, here we got formula for nth term of arithmetic progression. This is the formula that you have to remember. Tn is equal to a plus n minus 1 into D. This is called nth term of arithmetic progression. This is nothing but the nth term of AP, or which is also called general term of AP. Let's try to understand its significance. What is the importance of the nth term in any arithmetic progression or any sequence? Okay, so here I am starting with this simple example. Let's consider a sequence 1, 3, 5, 7, 9 and 11 that we considered previously. And you know that this is in AP. its first term is nothing but a equal to 1. And what is a common difference in each and every term? Common difference is 2, right? And here I am mentioning the formula for Tn is a plus n minus 1 into d. Let's substitute the value of a. So value of a is 1, n minus 1. Value of d in this case is 2. Okay, I am simplifying it further. So let's try to understand what is the significance of the nth term. I am multiplying 2 inside. This is 2n minus 2. So final answer for Tn is 2n minus 1. Is it correct? Okay. Now let's try to understand what is the meaning of nth term. So once again I am repeating, nth term means not the last term. Nth term represent each and every term of the sequence. So here I am marking 1 as a first term, 3 as a second term, 5 as a third term, 7 is the fourth term, 9 is the fifth one, and 11 is the sixth term of the AP. So right, okay, now let's see the magic. If you substitute n equal to 1 in this formula of nth term, so that indicates T1, it's a twice of 1. I'm substituting n equal to 1 in it. What is your answer? Answer is 1, which is nothing but the first term of the sequence. So T1 in this case is 1. Try to observe. If you substitute n equal to 2 in this, T2 becomes twice of 2 minus 1. 4 minus 1 gives you 3, and 3 is nothing but second term of the sequence. Right? So if you want the fifth term of the AP, do one thing, directly substitute n equal to 5 in this formula. So this becomes twice of 5 minus 1. So friends, 10 minus 1, is it 9? And if you observe, 9 is the fifth term of the sequence. So right? So this is the importance of the nth term. Nth term represent that entire sequence. Right? Nth term represent each and every number in that sequence, right? Which is visual or not visual also. If you check in this entire sequence, we don't know the 20th term of the AP, but you can quickly find out even the 20th term of this sequence just by substituting n equal to 20 in this nth term. So please substitute. This is 2 into 20 minus 1, 40 minus 1, answer is 39. So 20th term in this AP will be 39. So try to observe, this is nothing but the importance of the nth term. Nth term is called general term of arithmetic progression. It represents each and every term that belongs to the arithmetic progression, and formula for nth term is this one. Please remember, formula for Tn is a plus n minus 1 into d. Okay friends, so let's revise the next terminology from arithmetic progression, and that is nothing but sum of n terms of AP. Right? And for the sum we use S, and we want summation of n terms, so it is represented by the symbol Sn. So what is the meaning of sum of n terms of arithmetic progression? So finding sum of n terms means simply you have to add all the terms up to n from the beginning, right? So it is all about adding all the terms of arithmetic progression right from the start up to the nth term. If I say S5, that indicates you have to add first 5 terms of arithmetic progression. If I say S3, simply add first 3 terms of arithmetic progression. But what if I say I want addition of first 25 terms? It will be a lengthy task, right? And for that you must know this formula for Sn. I hope every one of you remember this basic thing. Formula for Sn is n upon 2, 2a plus n minus 1 into d. So this is the formula to find sum of whatever may be the n terms given. Right? So this is the formula that you have to remember to obtain sum of n terms of arithmetic progression. So please remember this formula, very important one, and terminologies remain same. N means that term given. If they says yes 7, n in this case is 7. If they says yes 9, that is sum of 9 terms, then n is 9. If they say sum of 7 terms, then n is 7. If they say yes 3, that indicates sum of 3 terms. So n in this case is 3. So right, n is all about the term they mention. A is nothing but the first term of AP and D is nothing but the common difference. Let's try to find sum of n terms of this example. So here I am taking a sequence in AP 1, 3, 5, 7, 9 and 11 and so on. And you know that we already discussed this is in AP. So the first term of this AP, A is 1 and the common difference in this case is 2, right? And let's say we want sum of first 5 terms, or let's say we want sum of first 4 terms of this AP. So sum of 4 terms means they are expecting S4. Finding a S4 means T1 plus T2 plus T3 plus T4. So this is actually a manual way of finding a summation, means 1 plus 3 plus 5 plus 7. So right, so this is nothing but S4. So this is the way that you have to find the S4s, right? So what is your final answer? Is it 16? Okay, but the real problem lies when they gives you number of terms. Like we want summation of first 20 terms, summation of 15 terms. We cannot do this thing manually. For that you have to simply apply this formula. Let's cross check this entire manual thing using this formula. So here formula for Sn is n upon 2 2a plus n minus 1 into d. And if you want S4, so let's try to calculate it for S4. S4 means n in this case is 4. So right, so here I am substituting n as a 4 by 2 twice of first term. So if you observe the first term of the sequence is 1, then n value is 4 minus 1, and what is the value of d? So d in this case, or the common difference in this case, is 2. So here this division is 2, this is 2 plus 3 into 2. So please simplify and cross check your answer. This is 2, 2 plus 6, 8 into 2, which is 16, which is exactly equal to the thing we calculated manually. So right, so friends, this is the way that we try to find sum of n terms of arithmetic progression, and this is the formula that you have to remember. Formula for Sn is n upon 2 2a plus n minus 1 into d. So right, okay, so once again I am repeating, we are trying to revise the basics of arithmetic progression because we want to continue this chapter with geometric progression. And before understanding all the details of the geometric progression, you must know what is there in arithmetic progression too. And this is just a quick revision of arithmetic progression. There are few properties, few important things that you must know about arithmetic progression. The first thing is, if the sequence is in AP, let's say 1, 3, 5, 7, 11, 9 and 11 and so on. So first property of arithmetic progression is if you add something in each and every term. So let's say I am adding x in each and every term, like 1 plus x, then 3 plus x, then 5 plus x. So whatever that you want to add, but make sure that you add in each and every term. Then that resulting sequence, since the previous sequence which is given is in AP, then this resulting sequence is also in AP. There is no need to cross check. So you can obviously take a subtraction of successive terms and you will observe that the ratio or the difference remains same. So what is the property number 1 is, if you add any number or any term in each and every term of arithmetic progression, then that resulting sequence is also in AP. Then property number 2, if I say this is the given sequence in AP, and if you multiply each and every term by x, like 1 into x, then 3 into x, 5 into x, 7 into x, 9 into x and so on, then that resulting sequence is also in AP. If the given sequence is in AP, then after multiplying with a certain term, the resulting sequence is also in AP. So these are the few properties of arithmetic progression that you already know. This is just a brief revision of that, and few important tricky things in arithmetic progression that you know: how to select numbers in AP, how to select numbers in arithmetic progression. So right, if sum is given, so let's say they provided you sum of numbers, sum of numbers is given. So right, this is just a brief revision of the problem that you solved under arithmetic progressions in previous classes. So if it is a question of three numbers in AP, three numbers in AP, so friends, how will you select that three numbers present in AP if sum is given? So please select in this order: A plus D, and A minus D. So here this A minus D is the first number, A is the second number, and A plus D is third number. So the question is, why we are selecting the numbers in this order, right? If you observe this number 1, 2 and 3, they are in AP. If you take a difference of successive terms, you will say the difference remains D. So right, so why we are selecting three numbers in AP in this particular way? The reason lies in this sentence: the sum of numbers is given. So if the sum of the three numbers is given, what will happen if you add all these three numbers? So friends, let's say the sum of these three numbers is given equal to something x or something 10. So that will give you added advantage. If you sum all these three numbers, this one of the unknown D get cancels out, and you can easily find out the value of A. And after that, you can find out D. Once we know A and D, means we can easily find out these three numbers in AP. So this is the simple logic behind selecting three numbers of AP in this particular way. So this is the pattern in which you have to select the three numbers of AP. If the question belongs to the four numbers of AP, try to recall four numbers in AP. So how to select four numbers in AP if sum is given? So here I am explaining in a simple way. So try to find A minus 3D is the first number, A minus D as a second number, A plus D as a third one, and A plus 3D as fourth digit. So this is the way that you have to select four numbers. This is number 1, number 2, number 3 and number 4. This is the way that you have to select four numbers in AP. First number is A minus 3D, second number is A minus D, third number is A plus D, and fourth number is A plus 3D. See what will happen if you add these four numbers. This D get cancels. If you observe, if you add these numbers, minus 3D get cancels with plus 3D, minus D will get cancelled with plus D, and that will leads to the value of A, and A will give you the value of D. Once we know A and D, we can easily find out all that four numbers. The logic is same, exactly similar to three numbers in AP. What if it is a question of five numbers in AP? Five numbers in AP with the sum given. So please select the numbers in this order: A minus 2D, A minus D, then A plus D, and the last one is A plus 2D. This is the order in which you have to select five numbers of AP if sum of the numbers is given. Logic remains same. So right, that we discussed in three numbers and four numbers. Okay, so what if sum is not given? This is the real question. So what if sum of numbers is not given? Then you are free to select three numbers in AP in ordinary way. So please select three numbers in AP in this way: three numbers in AP as A plus D, and a plus 2d. This is the ordinary way of selecting three numbers in AP. So this is the number 1, this is number 2, this is number 3. So since the sum of the number is not given, we don't have any advantage. Now you are free to select the numbers in ordinary way. If it is a question of four numbers in AP but sum is not given, so let me tell you friends, sum is not given in this case. If sum is not given, then please select the four numbers as A plus D, A plus 2D, and the last one is A plus 3D. Similarly, if it is a question of five numbers in AP but sum is not given, then please select the number as A plus D, A plus 2D, A plus 3D, and A plus 4D. So that's all friends. This is all about the quick revision of arithmetic progression. Hope this discussion will help you in recalling basic things of the arithmetic progression, and definitely this recalling all these concepts and basic things from arithmetic progression surely will help you in geometric progression, which is our next topic of discussion. Till then, goodbye and take care.